In this video, we'll use Kibana to monitor the health and status of our Elastic Stack. We'll look at Kibana and see how we can monitor Logstash, Elasticsearch, and Kibana itself. Alright, first let's look at Logstash. So there are a couple things we're going to look at. We're going to look at the health of the Logstash instance, the throughput, as well as the latency of indexing. So if we go over to Kibana, if we look at our normal tabs that we have on the left, now this is depending on your license, although I think monitoring is included for most. We'll go to monitoring, and we can look at Logstash. Alright, so we can do a couple of things. So we'll start on our pipelines. We've seen pipelines before, so I can click on this to see, alright, I have a Beats pipeline with a queue. I'm doing about 0.2 events per second. Yeah, that's good. Here are the other things that are cool. I can click on nodes, and I can say, okay, I have a local Logstash node. It's using 2% of my CPU, 0.29 load average, etc. JVM heaps. Events ingested is a total running count. It's fun when this gets into the millions. And then you can see things about config reloads, which it can do on the fly if it's configured to do so. So if we click on that, though, this is one of my favorite charts. We can look at this specific node. So imagine you have a distributed Logstash collection. So you could have, dozens or hundreds of nodes running Logstash sending to one Elasticsearch cluster. So you can drill into all the various nodes on your system. So here we can see things like events received per second, events emitted per second. Hopefully those are the same. Event latency, that should be very little. That's end-to-end latency. JVM heap size for this JVM process for Logstash. CPU utilization, and then load of the server. So these two are server specific. Alright, so let's see what else we can see. We can look at the nodes. We can look at the overview of Logstash. So here's a good one. Event received rate is how many events Logstash is receiving off from all of its various inputs. Event latency is end-to-end pipeline. So the bigger this number gets, the slower your pipeline is. That's very important to monitor over time. Make sure your pipelines do not bottleneck you. And then events emitted rate per second should be, you hope, the same as your events received per second. Unless you have a filter that's dropping events, in that case, you'll see a lower number over on the events emitted per second. Now we can look at we can monitor Kibana within Kibana. Because remember, Kibana runs as a node process on the server, and it serves the web UI so you can deal with it. Behind the scenes, Kibana is interacting with Elasticsearch frequently, so you will get to see some metrics there. So we'll go to monitoring again in our Kibana application. We can see Kibana here. A couple of heads-up pieces of data, total number of requests, max response time, 2 seconds. That's pretty slow. And then instances. We have one instance of Kibana. If we click on Overview here, we'll see the number of client requests. These are bucketed depending on the time range you have up here, and then the client response time. So averages is typically what you want to see, or you really care about. You'll watch your maximums to see spikes. If your CPU gets too high or network gets throttled, these can change. This is going to show you how reachable, how interactive your Kibana instance is. The more you have people using your Kibana, these numbers will get significantly larger. And now we can monitor Elasticsearch. So there's a whole lot of data in here. I have 2 slides to go over real quick, then we'll jump it back into Kibana. But we can see search and indexing information. So this is overall the state of your cluster. It's showing you your overall usage via search, the search rate. So that's how many searches per time period you see. The search latency tells you how long does each search take. If the search latency goes up, that means you have people executing searches that are making your cluster think really hard. So if your cluster is indexing a ton of data and the indexing is taking most of the CPU, then searches will slow down, or vice versa. If you have people searching too much, then your indexing can go down. So this is where we get into a lot of opportunities to scale and to configure our Elasticsearch cluster to be able to handle these scenarios. So there are different things you can do to optimize reads and writes. There are ways you can split reads to a couple of servers and writes to a couple of servers. We'll get into some of those scaling components in a later video, but for now I just want to show you these metrics. And then when we talk about Elasticsearch again, Remember, it's a distributed system, so we have different nodes or different instances on the cluster, and so we can see the system health and some high-level metrics about each node. This will look very familiar since we just looked at the Logstash node health. Let's jump over to Kibana again. So we'll click on monitoring on the left. Now here, Elasticsearch at the top, we have more data. So let's start left to right. So we'll go our overview, version 6.1.2. It's been up for 32 minutes because I've been taking it up and down. And we'll click on overview. So here's where we're talking about those rates. So we have our search rates, upper left-hand corner. So it looks like I'm maxing around 8 searches per second. As of this point in time, it's all Kibana. Kibana's doing all my searches on this node. Indexing rate is pretty low, but you want to watch this for spikes over time, especially when you start seeing things like, a gradual decline in indexing rate. That's a problem. Or let's say lower right hand, we're looking at this indexing latency. If we see a gradual increase of indexing latency, you have some sort of cluster health problem most likely. Unless it gradually increases and then peaks out at a reasonable number, then no big deal. But there's so much knowledge you need to gain on your Elasticsearch cluster by just watching it over time. None of us can truly plan our infrastructure on day one or before we even start putting data into Elasticsearch. But thankfully, Elasticsearch is built so you can make some changes over time with your configurations and whatnot. So again, search latency is how long it takes a search to execute. Those should be really low because Elasticsearch is super duper fast. Now we'll click back on the cluster name, and next we'll look at the nodes. I have one node, very small 7 gig disk. I have 2 gigabytes available. Heap size 39% is being used of the Java heap. So here we can see right now I have one node. We're going to get into this a lot more in our scaling lesson again, but right now we'll see this star means it's a master node. I have one node, so therefore it pretty much has to be a master node if I want to put any data into it. But we can see the number of shards on this server, disk space, and whether it's trending up or trending down. These are great overview metrics to look at. Status green in this one. So then I'll look in here, and this is more system health information. So general latency of the server, CPU utilization. Again, these are things to watch depending on how many searches and how much indexing you're doing at any point in time. Retake that one, pardon me. This is dependent on how much searching or how much indexing you're doing at any point in time. Heap memory usage, again, you gotta configure your heap, your JVM Java heap, so you have enough overhead to be able to handle some spikes in indexing or searching. How much memory is being used for indexing? In this case, is very little because I have very little data coming in. System load is a very Unix type of metric. And then segment count is file system segments. And now let's go to the final part of the Elasticsearch overview. We'll look at the indices data. So this is a fun one because depending on the system you're using, this could look different. So if you think about these time-based indices, like the file beats and the metric beats, 2018, 02, 21. So you can see that there's an indexing rate for each index. Now, if you're running Logstash or something like that, where it's doing these indexes, and you're maybe taking distributed data and putting it into your cluster, you can see some funny things in here. If maybe one node is really slow, you might see an index name that's 3 days ago getting data. That's a great indicator that something is wrong. Typically, you will see today's index at the top, whatever data you're putting in. And then you'll see the previous day's data just kind of falling off this list. So now, we're not going to get into this health too much here of each index, because right now they're all yellow, which means the backup shards they can't go to another server, so they're just kind of sitting there, which means it's yellow. We're going to talk about that a lot in the scaling lesson, so come back for that one. But let's look at this for the metric beat, for this very specific index. You want to see things, how large the index memory is being used at this point in time or over time. What is our search rate over time? How much disk space it's being used. So disk space and document count, assuming you're constantly putting data into this index, you will see these go up and to the right, and that is okay. This is a great way for you to determine or use some calculations to figure out how much data you're going to need per day or per time period, and so then you can calculate out into the future for planning your disk usage and all that good stuff. So this is the overview of what an index health looks like within Kibana.
In this section, we covered an overview of the visualizations that are available within Kibana. We've built a few different visualizations using the data we have available and combined them into dashboards. So dashboards are kind of your heads-up view that we can then share links to them, or we can download a screenshot or a PDF or something of our dashboards that we can then share with other people. We've looked at the different ways we can share the dashboard, the different URL types. And then we finally looked at what I would call a built-in dashboard for Kibana, where we can monitor our Elastic Stack from top to bottom.
All right, in our next section, we are going to explore XPack.